All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about branching or branching in Git. Dude, between yesterday and today, I've actually been making a bunch of progress behind the scenes. There was a bunch of different types of research that I was doing with um, through Gemini, and uh, well. Hold on. Sorry. Give me a second. Yeah. There was a bunch of research that I was doing through Gemini, and uh, that basically means, sorry, I keep stopping at that point because I'm not sure what to say next. Um, there was a bunch of research that I was doing. There were a bunch of Gemini conversations that I had open, and so I was just going through and clearing out a bunch of those conversations. Now, one convo that I had with Gemini was about terminal-based hex editors, not hex viewers or hex dump utilities, hex editors specifically, and terminal-based hex editors specifically. I wanted to see what my options were, and it turns out the options are a little on the limited side. They are you have some options, but um, most of the options that I've seen, they are on the GUI side. There's a very famous, very widely used tool called, I think it's called ImHex. I think so. Hold on, let me look that up. I just had the GitHub repo open. Yeah, it's called ImHex. This is a GUI application in which you can do all sorts of hex editing and viewing. It goes way, way beyond just just a simple hex dump. There's a lot that you can do with it. It's a fairly sophisticated application with an insane amount of features that are very useful for people who do work on the byte level, people who have to um, change, sequences of bytes within binary files, or even within like non-binary files, like just regular data files. People who have to change data within them, people who have to find data within them. It's useful for all sorts of different purposes, and especially it's useful for reverse engineers, people who do reverse engineering stuff. But going back to what I was talking about, um, I couldn't find too many tools. One thing that I did find, which was thanks to Gemini, was there's a tool that's part of Ubuntu itself. It's a tool called XXD. This allows you to create a hex dump out of some data, or um, do the reverse of that, which is creating the data out of a hex dump. So for example, I can do echo ABC and I can pass that into, okay, let's put it within double quotes. I also just remembered something here. Give me a second. Okay, yeah. What was I doing? Okay, so I can do echo ABC and I can feed this into XXD, and you can see it gives us the the output. The output is basically in hex. Um, so it's the ASCII characters for A, B, and C. And additionally, I think at the end there's a I forgot what that character is supposed to be. In ASCII, I don't know if that's like end of line or new line, or I didn't add a period there. I didn't add like a full stop, so I'm not sure. Hold on. Line feed, which translates to the new line character. Okay, I think that's a thing with echo. I believe there is a way to get echo to not, yeah, okay. Um, do not output the trailing new line. So let's try that. I think it said N. Yeah, there you go. So now we have perfect A, B, C, and those are our characters. Now, the great thing here is we can actually feed the reverse of this. Actually, okay, we can pass it into this and do reverse, and now you can see it printed out ABC. Um, it didn't go to the next line because there's no new line character after that. Um, which makes me curious if, hold on, what if I didn't do this? Okay, yeah, so that is a new line character. Okay, this is great, right? But what does this have to do with hex editing? Right. Now, let's create a file called sumbin01. Okay, I actually haven't opened up a binary file in NeoVim to see what the value will look like. Okay, so do I have a sum01.bin? I do. I don't remember what I put into sum01.bin. There's a binary flag that NeoVim has, right? Okay, hold on. There. There is a B flag. I don't remember what it does though. Hold on. Let me. There was a B flag. I can't remember exactly. Hold on. Wait. Nvim binary. Binary mode. Okay, to open a file in NeoVim's binary mode, launch it from your terminal using the B flag. This disables the line ending conversions, formatting, and plugin features that could corrupt raw data. You know what? I've never tried out NeoVim's binary mode. This just occurred to me. I've never actually tried out NeoVim's binary mode. Let's see what happens here. Okay. I'll have to do research on what that is. Okay, ABC. Okay, this is a binary file that I have open here, and what I'm gonna do, I forgot what I was. Wait, let's close this and not open it in binary mode. So we have a file here, sum01.bin. This file has the text ABC in it. What I want to do is convert this to hex. So it's going to output the hex dump of this. And then I want to edit the characters in the hex dump and write that back to this file. So what I'm going to do here is do this and what was it? XXD. So this creates the hex dump. Now what has happened here when I ran that command, let me show that again. So we have this percentage character, which basically means the entire buffer. So it's gonna read the entire buffer, and then this I believe is to say that the next, like after this character, we're going to be issuing a command. Give me a second here. Sorry, I'm just looking something up. I'm actually looking at the conversation. Oh, the exclamation mark means pipe this range into an external command. Sorry, it doesn't mean that you'll be entering a command. I thought it was in it was a way to let NeoVim know that the next thing is going to be a command. No, apparently this means that you pipe the entire range that you have selected. You pipe that entire range into whatever command is being typed next, which in our case is xxd, and that gives us this. Hold on, that's confusing. Why does it look like that? Oh my God, I just, hold on. Wait, I, yeah, it's because I tried to create a hex dump off that hex dump and that became confusing. Okay, so restarting that. So this is our text ABC, and we enter this command. You have the percentage thing that represents the entire range, so it's the entire buffer. And then this exclamation mark is essentially a pipe saying that pipe all of this data into, or pipe this range into the command. The command in this case is xxd, and that produces this hex dump. The hex dump shows an offset, which is the column on the left side. It shows the bytes, which are these two columns. There are 4 bytes being shown here. There would be more here as well. I think up to 8, 16. I don't remember how many it shows. And then in the third column, we have the actual like text, the text that these bytes represent. This is our hex dump. Okay. Now here's the great thing. We can edit this, right? And because XXD accepts this exact format as input, if you are trying to reverse the hex into, or convert the hex into, printable characters, because XXD accepts the input in this exact format, I can edit the bytes here and then hit save, and then I can pass this exact thing back into XXD, but with the reverse flag, and that gives us our new data. The new data here is just that I incremented the A byte. So instead of 62, sorry, instead of 61, which is the ASCII character for the hex for the ASCII character A, it became 62, which is the hex for the ASCII character B. So now we see BBO. I did not realize I was doing that. Okay, well, so this is uh, this is how we can do hex editing in NeoVim. And I find this really interesting. There was actually another tool that I had found as well. I think it was called HexView. It's called HexView, but the plugin claims that you can edit, you can do actual hex editing using it. It's a NeoVim plugin. Um, so you can install it in NeoVim and then you can use it to do hex editing. I wasn't able to get it to work though. I don't know if I was doing something wrong or like what was the problem? I have no idea. But I couldn't get it to work. Maybe I was supposed to open the file in binary mode and I haven't really played with binary mode. I don't think we need to. Either way, I wasn't able to get it to work. That being said, this method is actually pretty great. In fact, what I could do is I could assign a key binding to do the hex dump. The thing is, what's happening here when I type that command, when I type this, all this is doing is reading the buffer's contents and then piping that into XXD, and whatever output XXD gives, that gets written into the buffer. So we have essentially overwritten, we have words, holy shit. We have essentially overwritten our entire file at that point. This is our file at this point. So if I now save this and let's say I come here, I don't know what's in Yahtzee here. Oh, okay. Why did I have that open? I can't remember why I had that open. What was that pointing to? I think that was pointing to the Twitch VODs. Dude, I should have looked at that. I saw there was like a bunch of videos there, so before it tried to load the what do you call it? Before it tried to load the thumbnail of something, I just closed Yahtzee very quickly. But this is supposed to be okay, I don't know. I don't remember. Whatever. So empty directory sum01.bin. So if I do this, this is now the text that's within sum01.bin. This looks like a hex dump, right? But this is quite literally the characters that have been written here. So if I did an actual hex dump of this, let's, how do I pass this in? Okay, would this work? Yeah, this is what it looks like now. You can see the zeros. There's a bunch of zeros there. At the beginning, you can see one character for the colon. Then you can see 6 1 2, no, sorry, 6 1 6 2. So like each of them has been now, you know, made its own separate character. This is not a hex dump anymore. This is a hex dump of a hex dump, if that makes sense. Um, but yeah. So the entire buffer, the entire file has been overwritten with the hex dump data. When we do our change and we, reverse the data, all we are doing is editing this and then feeding it into, um, wait, there. All we are doing is editing it and feeding it into, feeding the result of it back into our buffer. So in that aspect, it is a little bit of an iffy thing, which makes me wonder if I should, maybe consider creating a terminal-based hex dump, or sorry, hex editing application. That would be a good, um, that would be a good, what do you call it? That would be a good practice exercise kind of thing when I'm learning Ratatouille. Because I'll be making it using Ratatouille, definitely, like 100%. I'll be making it using Ratatouille. I probably, I could probably use their layout elements. I shouldn't have to, create the layout myself, or rather, to be more specific, um, hex dump C sum01. This is what I would generally be using for creating a hex dump. If we are doing a hex dump of a hex dump, and I save this, this is what it would look like. Additionally, there is a tool that I installed yesterday and then also uninstalled, but I'm gonna reinstall it again. There's a tool called, sorry, there's a tool called Hexel, which is also a hex viewer, but I believe it, for one thing, it has like colors, so it'll probably assign different colors for, different bytes that have some meaning. But I believe it also has like different modes in which you can view stuff. And it's a Rust-based application, so I'm expecting it to be pretty fast. Oh, speaking of things being fast, when I do make this hex editor, which I'm still surprised that there isn't a Rust-based, terminal-based hex editor application. There is though. I mean, some people have worked on like their own, versions, but I haven't found like very widely used ones, if that makes sense. And even looking it up on Google, it doesn't seem to be helping. Um, Gemini mentioned that I'm Hex also apparently has a CLI. Um, I haven't looked into that too much. Okay, so I'm looking at an answer here. ImHex has a command line interface that you can use. Run imhex so and so to see what's available. The subcommand you're looking for is imhex pl. There's also a standalone CLI for the pattern language itself, without any imhex stuff that you can build yourself from library sources. Uh, okay. All right. Okay. So, yeah, I wanted to talk about this. I wanted to mention that, this is one of the things that I've been up to. This was interesting to get into. I don't remember how I got to this point though. Um, but yeah, wait, can this be decremented or incremented? No, it's just numbers. Yeah, it's just numbers. Yeah. Wait, would this be interpreted as hex? I don't think so. No. Now, what if we did this? No, still not hex. Let's try 0x, I don't know, FF. Okay, that's being interpreted as, um, is it because of the 0x? Oh, it's the 0x. Okay. So if we do that, there we go. Okay. Yeah. So it counts, it increments in hex. All right. Okay. You know what? I think we are ready to get into or get back into Git branching. Holy shit, dude. This has taken longer than I thought it would, but I'm glad because I got to learn about Git and, well, Git's inner workings. More importantly, I got to learn about Git's inner workings, and pretty soon I'm gonna start using Git a lot more regularly. So I feel like once I've used it a bunch, the workflow is kind of gonna stick in my mind. It's one of those things where, like, when I learn something, I need to use it. Unless I use it practically for at least some amount of time, I'm gonna start to forget things about it. And Git happens to be one of those kinds of things that I need to keep practicing, or at the very least, once I've learned it, I need to practice it a bunch, immediately after learning it, in order for the practical steps to stick in my mind, so I can then remember it at some point in the future. Give me a second here. I'm just going to open up my chat on my phone. Uh, okay. All right. Great. So where were we? Creating a new branch. I believe I did this already. Hold on. Let's go back to some repo O2. We created a branch called testing. I believe we checked it out as well, or I think by default it was already selected uh, in Git UI. Yeah, yeah. So, git branch testing. This creates a new pointer to the same commit you're already on. Okay, great, awesome. How does Git know which branch you're current? Okay, so this is talking about head. All right, great. Note that this is a lot different from the concept of head in other VCSs. All right, great, cool. I think the assumption here so far is that we haven't switched. So, you know what? I will do it because there tend to be a few like differences between can I delete this branch? Okay, I'm missing the delete op oh, it's because I'm currently on that branch. Now I can delete this. Yes, okay, great. So, what we are going to do is create a testing O2 instead. So git branch testing O2. That's our branch. Now we're going to run this, and now we can see branch, or sorry, testing O2, which is the branch that we just created, is showing up at the end of that list. Head is still pointing to master because we haven't checked out the branch. Okay, you can easily see this by running a simple git log, a simple git log command that shows you where the branch pointers are pointing. This option is called decorate. Okay, we are doing that. You can see the master and testing branches that are right there next to so-and-so commit. Okay, cool. Switching branches. To switch to an existing branch, you run the git checkout command. Let's switch to the new testing branch. By the way, so they're using git checkout here. However, switch is apparently a newer, more preferred version of checkout, or specifically when you want to switch branches, because checkout apparently does something more than just switching branches. We still use the terminology, currently checked out branch, because that's like a Git terminology kind of thing. However, we can still use switch, or we now it would be preferred if we use switch when we are switching branches. So I can do testing O2, and now we are switched to testing O2. I could also do checkout, though I don't think it's gonna switch because we're already on that branch. Yeah, it says we're already on testing O2. Okay, so now that we are on this, let's go back to Yahtzee and take a look at head. Head says that it's pointing to testing O2. If we go into refs, heads, testing O2, now we have testing O2 pointing to that commit. Great, awesome. Actually, no, it's not pointing to that commit because we switched. It was already pointing to that commit. It's just that now head is pointing to this branch. Okay, all right. Sorry, zoned out. Okay. Um, right. What is the significance of that? Significance of what? Well, let's do another commit. Significance of what? Oh, head points to the current branch. Oh, yeah. Okay, so the branch is going to progress then, right? In this case, in order to be able to see this, um, here, we can open up Siri. Actually, no, we cannot because you guys are not going to be able to see the graphics that you're supposed to see um, with the branch. I need to find a different way to show. Actually, there's a graph, isn't there? Yeah, yeah. This might show the branching thing once I make the commit. Okay, so we're gonna make a commit. Oh, this has old information. Let's open that up again. Right. Oh God, there's a bunch of stuff here. Um, there's a bunch of changes. Let's do something here. Hold on. I need to delete. Let's delete this branch and let's make the commits. Okay. Um, what is it? Sixth commit, I guess. All right. Now let's. Oh, okay. Our tracking branch is still on the old commit. I just noticed that. Yeah. Okay. That's a good thing to keep in mind. The tracking branch is also being, well, tracked here. It's not just the master branch and the other branch that I'm going to be creating. Let's do testing O3. Oh, git branch testing O3, and then check out testing O3. And now let's um, yeah, let's make a change here. This is a change from testing O3 branch. All right, that's done. Now go into Git UI, add this. Actually, what's the branch that we are currently on? Testing O3. Okay. Oh yeah, it does mention there, testing O3. Commit first there. First commit from testing O3. Okay, that's done. So now we have something interesting going on here. We have our remote tracking branch, which is one commit behind, now two commits behind actually. We have our master branch, which is one commit behind, and we have our testing O3 branch, which is up to date. I'm not sure what term to use there. No commits behind, zero commits behind. Give me a second here. Oh, okay. All right. Okay, so now I want to see a graph of this. Hold on. Is there any way that I can look at some sort of graphical representation that shows some sort of like lines and stuff? Um, Hold on. I want to see. Oh, actually, I have a way to show it to you guys. I just realized that. Let's come here and here. And from empty directory, we're going to go into some repo o2 and open up Siri here. But it's pretty small, so I don't know how well you guys are going to see it, but you'll see it. No, actually, you don't see it because it is small. Okay, let's just go back to this. Let me ask Gemini. Hey, so when I'm using the Git CLI, is there a way for me to see a commit graph with lines and stuff? Yes, absolutely. The Git CLI has a built-in way to do this, and it actually looks surprisingly good for a terminal too. The secret sauce you are looking for is the graph flag, okay, usually combined with a few other flags to make it readable. Okay, there's one line and all and decorate. Let's do all. Uh, did that make a difference? I don't know if that made a difference. I don't, yeah, I don't know if that made a difference. Hold on. A fun trick. Oh, that's to create the alias. Okay. I guess we are not seeing lines because there isn't necessarily, lines to draw. I am curious about what that would look like though. Let me just Google this. Git log graph. Yes, okay. It does create lines when you actually have lines to be created. Um, yep, yep. It's going to create lines when you actually have lines to be created. I wonder if Git UI would display something similar. But yeah, it's I won't be able to show it to you guys in Siri because I can see it in Siri. I can't see it through Tmux though. The That part of the graphics doesn't really show up very well. I don't remember what the issue was. I'll have to look into that. But okay. Um, where were we? Okay, so we've made the change. We've committed the change as well. And now we should be seeing that head is pointing to testing o3. Testing o3 is pointing to a new commit. Um, master is pointing to a different commit, right? And head is pointing to testing o3. Okay, this is interesting because now your testing branch has moved forward, but your master branch still points to the commit you were on when you ran git checkout to switch branches. Let's switch back to the master branch. Okay, let's do that. Let's go here, switch here. So now we are not seeing that commit anymore, the new commit that we made. Let's switch back here. Okay, okay. All right, note, git log doesn't show all the branches all the time. If you were to run git log right now, you might wonder where the testing branch you just created went, as it would not appear in the output. The branch hasn't disappeared. Git just doesn't know that you're interested in that branch, and it's trying to show you what it thinks you're interested in. In other words, by default, GitLog will only show some commit history below the branch you've checked out. To show, oh, it's just talking about like using the all flag. Okay, great. So when we check out the master branch and we look at Yahtzee, now head points to master. Okay, cool, cool. Okay, that command did two things. It moved the head pointer back to point to the master branch, and it reverted the files in your working directory back to the snapshot that master points to. Okay, cool. This also means that the changes you make from this point on forward will diverge from the older version of the project. It essentially rewinds the work you've done in your testing branch so that you can go in a different direction. You know what? Let's do that. Let's not make a change to the same file though. Let's make a change to sum04. Sum04 has a lot of stuff. Um, what about sum02? Let's do sum02. Okay, we can delete this and then save and then come here, make our commit, seventh commit, committed, and we are now here. Okay, what does the graph look like now? Oh, let's do all as well. There it is. Okay, there's our lines. So now we can see branching being shown. Sorry, zoned out. Okay, so now we can see the branches or the lines, the connections that I was looking for. I was looking for these kinds of connections. I wanted to see if we can see this kind of stuff. Also, I want to see what this looks like in Siri. You guys are probably not going to be able to see it, but yeah, we can see it here as well. It is a little bit obstructed. I am not sure how well you guys will be able to see it because I have like the text and stuff. Um, for the sake of, okay, hold on. Let's split this horizontally. Wrong split. Let's split this vertically. Okay. And now I want, oh, actually, that wasn't the problem, was it? What I needed was this. Yeah. So now you guys can see the the graphic that I was looking for. It's basically this thing. But yeah, yeah, now we are finally able to see the branching. Great. Awesome. Carrying on. Um, sorry, zoned out. Okay, that command did two things. It moved, I think I read this. It moved the head pointer back. Okay, that's done. This also means that changes you make from this point. Okay, it essentially rewinds the work you've done in your testing branch, so you can. Okay, great. Switching branches changes files in your working directory. It's important to note that when you switch branches in Git, files in your working directory will change. Okay, okay, all right, that makes sense. So, okay, I was trying to understand how branches are connected to Git objects. Like I was trying to visualize that because when we were learning about Git objects, we learned about, okay, we have blobs, we have trees that point to blobs and possibly other subtrees. We and then we have commits. So blobs, trees, and commits. These are all individual objects, right? Blobs are the files themselves. Trees are representations of directories, and the trees contain blobs for they contain blobs representing the files that are within those directories. And then we have commits. A commit will usually point to one root tree, and that is the root directory. And if the root directory has subdirectories, then that tree is going to point to other trees, and you're going to have like a tree-like structure going on there. Fine, this is great. I was trying to visualize how how we look at this from the point of view of branches. Like what is going on there? Sorry, zoned out. Okay. Um, what was I saying? Yeah, I was trying to visualize this, and I think I kind of am able to visualize this because head points to a branch, right? We have the branches are stored in the branches are stored in refs here, and each of these branches points to a specific commit. That's the tip of that branch, so to speak. Right. So, in terms of visualization, each of these branches is pointing to a specific commit object, and then that commit object points to the snapshot, and that snapshot is our, working directory's representation. So then that's what changes the working directory structure. Let me, just for the sake of confirming it with Gemini, or just for the sake of confirming it, let's ask Gemini. Wait, give me a second. I want to look at the graph. Commit graph, horizontal. There's a horizontal version of the graph. When given a range of commits to display, and a commit in that range, only display commits. Wait, a more detailed explanation as follows. Right, horizontal line of history. Okay, this is a different thing. Let's try that though. Hold on. let's do git log. I'm hoping instead of commit, it accepts, what do you call it? I'm hoping instead of commit, it accepts head, and it just, you know, parses that. Ancestry, did I spell that right? Yeah. Path. Is this how you do it? Oh, hold on. Wait, I've given the all flag. I don't know if that's going to cause an issue, but let's find out. Okay, I'm not sure what this flag is supposed to do. I'll let this go for now. Let me ask Gemini. Hey, so I'm learning Git. I recently learned about Git objects. I know that blobs point to, well, blobs are the files. Trees, or I should say represent. Blobs represent the files. Trees represent the directories, and together they make up, I think tags are part of the snapshot. Okay, anyways, uh, and together they make up a snapshot. I also know that commits point to um, root trees, and also give some other metadata. I also know that branches point to commits, and unless in a detached head state, head usually points to a branch. I've been trying to visualize this working mechanism in my head. Um, am I right to visualize it as we have, wait, let me add a colon there. We have multiple branches, each pointing to a different commit, and the commit points to or represents a snapshot of the working directory. And thus, when we check out a branch, the working directory is changed to represent the snapshot that the latest commit in the branch is pointing to. This is a hell of a sentence, but I'm hoping Gemini gets it. Okay, you hit the nail right on the head. Your mental model is incredibly accurate. For someone just learning Git, visualizing it in this way shows you, okay, thank you, great, awesome. To give you complete confidence, let's validate and slightly refine exactly what happens during the Git checkout moment. The anatomy of a checkout, your visualization of the relationship between head, branch, commit, and tree snapshot is spot on. When you run git checkout branch name, Git essentially executes a three-step process under the hood to align your physical workspace with its internal database. One, it moves the head pointer Git updates the head file to point to your chosen branch. Sorry, zoned out. Uh, what was I saying? Sorry, I've zoned out so many times during today's stream. Anyways, so the three steps, it moves the head pointer. So Git updates the head file to point to your chosen branch. Then it updates the index. I just realized that I probably haven't. There was I was looking for ways to visualize what's in the index file. I don't remember if I ever got around to doing that. Yeah, I don't remember, dude. Like being able to visualize what's in the staging area. Hold on, I'll open up another conversation. Hey, I'm learning Git. I've used, oh God, I accidentally hit enter. I've used tools like ls ls files, ls tree, um, and cat file to view various Git objects. I'm curious about how I would um, view the index file, which, from what I understand, is the staging area. Okay, right. Um, the Git index is indeed your staging area. However, unlike regular commit or tree objects, the index is a binary file that can't be stored as that isn't stored as a standard Git object. Because of this, trying to use git cat file on it will give you an error. To peek inside the index file. Oh wait, isn't ls files for does this show as the staging area or the working directory? I can't remember. Wait. Show information about files in the index and the working tree. Okay. Um this command merges the file listing in the index with the actual working directory list and shows different combinations of the two. Several flags can be used to determine which files are shown, and each file may be printed multiple times if there are multiple entries in the index or if multiple statuses are applicable for the relevant file selection options. Okay. Well, there's nothing in the staging area right now. At least I don't think so. Yeah, there's nothing in the staging area right now, so it's just showing what the working directory is. Let's see what Gemini is saying. Okay, the best tool for this is git ls-files. Since you've already used ls-file, you might actually already know the answer without realizing it. By default, git ls-files looks directly at the index. Sorry, zoned out. Okay. To get a detailed view of exactly to get a detailed view of exactly what the index is holding, use the stage or S flag. Okay, all right. But then this is meant to be the staging area. There's nothing staged right now. Though, though it's very interesting to see that it is pointing to the exact blob hashes of each of these files. So these are the hashes. If we look at, um, hold on, I'm gonna need to wait. What was the last change that we made? Okay, it was removing this. That is not a good example. What did I do in the sixth commit? I added something, right? Well, okay, forget about what I was trying to say. Basically, what I was trying to show was that, sorry, zoned out. Okay, what I was trying to show was that it's going to print out the data. I could still show it printing out the data using a cat file. I think it was P to get the data of this thing. So FE, we're going to look at sum O 05. FE971A. There's the data. It's a long file, so there's a lot of data in there. Okay, this okay, hold on. The low level tool, git open index. If you want to see the truly raw structure of the binary file without git parsing it into a clean list, you can use a hidden helper command called test tool. Um, okay, git test tool. This command depends on the git installation and is meant for git internal testing, but works natively in most environments. This will dump the raw cache entries and metadata directly from the binary index file. Okay, I'm curious about this. Git test tool. The stupid the stupid content tracker. Git is a fast, scalable, distributed revision control system with an unusually rich command set that provides both high-level operations and full access to internals. See Git tutorial. I didn't even know that there was a Git tutorial like manual page. How do I access that? Like this? Git tutorial. You're joking, dude. The entire tutorial is here. Well, kind of. Kind of the entire tutorial. How do we go to the next page? There has to be a next page for this, right? Part of the Git suite, the Git user manual. Oh, tutorial 2, Git core tutorial. I actually had a question regarding Git core because I saw a bunch of different processes pulling data from somewhere. I had to ask Gemini about that. I'll ask that question later on. Okay. let's do Git tutorial 2. Okay, and this directly jumped into the Git object database. Okay, is there a tutorial 3? Wait, this could have been like a super fast introduction to Git. Holy shit. Anyways, okay. Um, yeah, I was gonna do Git. Actually, I was looking at what do you call it? Here. After you mastered the basic concepts, you can come back to this page to learn what commands Git offers. Hold on, what did I just type? Test tool. Okay, okay. Okay. All right. Well, the one I'm looking for is read cache. Can I do this? Okay. Well, no. Um, what about now? I am not sure. Hold on. Yeah, no. Okay, let's just run this. It says test tool is not a command. I guess I don't have it. Okay, why does the index matter? You know what? Okay, I'll look into this later on. For now, let's go back to Gemini's explanation of the three steps that take place when you check out. So first is it moves the head pointer to point to the branch that you've chosen. Then it updates the index. I actually have a question about that. Wait, I'm confused. If the index is supposed to contain the staging area, and the staging area is mainly changes that have been staged, unless I'm mistaken about its use, um, then why why do I see, no, why does Git, what was it? LS files, I think? Yeah. LS files S show me my entire um, working directory. Okay, the short answer is the staging area doesn't just hold your changes, it holds a complete snapshot of your entire project. Here's why it works the way it actually, here's why it works that way and why it actually makes Git incredibly fast. The misconception, a delta versus a snapshot. It's easy to think of the staging area as a temporary shopping cart where you only toss the specific files you've changed. If Git worked that way, the index would only hold a list of modifications. But Git doesn't care about changes or diffs at its core. It cares about snapshots. That is, yeah, it cares about snapshots. The index is literally a cache of the entire working tree. Oh, I think I had the wrong idea. I think I had the wrong idea. Okay, okay, we need to make one more commit for me to kind of understand. Um, hold on. Let's do git ls files staged. Great. Okay. What does this do? Oh, okay. Yeah. Staged. So we have the hashes here. I'm going to make another change. This is a sentence. Okay, we're going to save this. Come here, commit the change. This is what the eighth commit, I think. Eight. Did I spell that right? How do you spell eighth? I just realized that I don't know how to spell eighth. So eight is EIGHT. Is eighth this? How do you holy shit, I just forgot how to or sorry, I just realized that I forgot how to spell the word eighth. Oh, there's still an H after the G. All right. Eighth commit. All right, that is done. Now let's list this out again. So I mainly made a change in what sum O2. So we should be seeing a difference in hashes between these two. Yeah, mainly you can see a difference between. Hold on, can I use ls files to point ahead? I don't think that works. Can I use ls files to point to wait, ls files does it take commits at all? It mainly loads the or it mainly reads the what is it reading though? It's reading the current working directory, right? I think so. Hold on. What was I? Sorry, I lost my train of thought. Sorry, zoned out. All right. Um, hold up. Can I use git ls files to list out um, trees from specific commits? Because I'm trying to find. Wait, no. LS tree does that, doesn't it? Does LS tree also give us the hashes? Yes, it does. Okay. LS tree gives us the hashes. So what we can do is, I believe this works. This doesn't work. There was a way to do this. There was definitely a way to do this. Hold on. Hold on. Hey, when I'm using git ls tree, how do I do head -1 or -2 or whatever? To look at the previous commit using git ls tree, you just need to use git's revision syntax. Oh, it's a tilde. Yeah, okay. So if we look at this tree, wait, let's clear this up and now do head and then head minus 1. Actually, actually, better yet, uh, if I create a unified diff between these two, um, I hope I do this right. Git ls tree. I don't think I'm going to do this right, but let's give it a try. Let's see. Git ls tree head minus 1, and then we feed that into delta. Uh, Hold on. Does the flag come afterwards? Diff options files. Yeah, that's done. Git ls tree so and so. Okay. So delta, no, diff. How did I do this the last time? I'm curious about that. How did I? Because this is process substitution, isn't it? The idea behind this is that it'll holy shit, I just noticed the time, dude. Man, we've been busy today. I've been in the zone and I just lost track of time. I mean, we've been making progress with this, so that's a good thing. We are almost at the end of the page, and there's a lot more interesting stuff to look into. Oh, we are pretty much done actually. There's like very little to read. What comes next after this? Basic branching and merging. Then branch management, branch workflows, remote branches. Okay, all right. Sorry, zoned out. Okay. How did I do that? Okay, it says invalid context length. Oh, can diff read between files? Hold on. Files are file 1 and file 2. It says invalid context length. No, there's something missing here. Hold on. I need to copy this and then that and copy. Okay, well, I think this is done, right? Yeah. Hey, can you tell me why this command is giving me an invalid context length error? Okay, the short answer is that you expects a number immediately after it to define how many lines of context to show. Because oh, did I make a mistake by adding the U flag? Was it supposed to be a small u? Oh, fuck me, dude. Okay, all right. Hold on. There we go. So my mistake was that I was using uppercase U, which is when you provide a certain number of lines, and the lowercase u is basically just a unified diff. So this is the unified diff format. The amazing thing about this, okay, the amazing thing, this blew my mind the last time that I looked into it. This is a unified diff format, okay? Um, it has a specific format that it follows. What this is doing is it is showing the diff between between this and this. That diff is showing the difference between these two, right? Um, what blew my mind is the fact that I could easily feed that that data that's in this format. I could feed this into Delta, and Delta is able to parse the entire thing and separate it to show me two different versions of the file. Sorry, two both the diffs. It shows me like the both of the data as separate pieces, which is what I was expecting. But yeah, this is the diff that I was trying to show you between the previous commit and this commit. So why was I doing this? I think I was doing this because I was looking at ls files this. Why was I forgot why I was looking into it. But okay, you know what? I think I'm gonna pause here. That's gonna be it for today's stream. Uh, we made some good progress today, that's for sure, and I'm super happy about that. And we'll continue again tomorrow, hopefully. I'll clear out more of my what do you call it? More of my Gemini conversations that I need to finish. And we're going to continue progressing with this branching thing. I think I'll continue doing the branching reading off stream as well, and hopefully cover as much as I can before tomorrow's stream, because in tomorrow's stream, we're going to be merging a branch into another branch. Tomorrow we're going to be merging our testing O3 branch into main or into master. But that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.